Welcome to another video. Today's topic is differentiation. Like before, I will be solving a range of questions, and please leave your questions in the comments. Let's start solving. It says the curve is such that dy over dx equals to 6 over root 4x minus 3, and p 3 comma 3 is a point on the curve. Find the equation of the normal to the curve at p, giving your answer in the form ax plus by equals to c. So in order to find the equation of the normal, I first need the equation of the tangent. Not the equation of the tangent, but the gradient of the tangent. I already have dy by dx. I don't need to differentiate. I can just use the value here and say that this is going to be 4 3 minus 3, and I get 6 over 9, which is 2. So gradient of tangent is 2. That would make the gradient of the normal as minus half. It's the negative reciprocal. And then I have y minus y1 mx minus x1. So I have 2y minus 6 equals to minus x plus 3. So 2y plus x equals to 9. Relatively simple question, because part 2 would then have been something. It looks as if it is a paired integration, but that's something that we can do later. Okay, then question number 2. It says the diagram shows the curve this and this, which crosses the x-axis at the point 0 1 1 0 and 2 0. The tangents to the curve at the point a and b meet at the point c. Find the x coordinate of c. Okay, so the tangents to the curve at the points a and b. So what I'm going to do is I'm going to first try to differentiate. Now I can't differentiate without expanding it first, so I'm going to first expand it first and say that this becomes x squared minus x when I multiply the bracket. Then when I multiply every term by x squared, I get x cubed minus 2x squared, and then minus x squared plus 2x. That gives me x cubed minus 2x squared minus 3x squared plus 2x. That's why I need dy by dx, because I want to find the gradients of the tangents. Okay, so that gives me 3x squared minus 6x plus 2. Then I need the equations of the tangents at the point a and b, so I'm going to first plug in the coordinates of a and say that x equals to 1. 3 times 1 square minus 6 times 1 plus 2. I get minus 1. uh, Constructing the equation, I get y minus y1 mx minus x1. Okay, that's the first equation of the tangent. For the other equation of the tangent, I'm going to plug in the coordinates of of b, which is 2. I get 3 times 2 squared minus 6 times 2 plus 2. Okay, so that gives me 12 minus 12 plus 2. Okay, that gives me 2. So y minus y1 m x minus x1. Y equals to 2x minus 4. Okay, then I have to say that these meet at the point C. That this means that they intersect at the point C. So I'm going to try to solve that and say that y equals to minus x plus 1 and y equals to 2x minus 4. I can do a simple substitution and say that 2x minus 4 is to minus x plus 1. So 3x equals to 5 and x equals to 5 over 3. I wanted the x coordinate of C, and that is what I have. 5 over 3 is a perfectly fine answer. Moving on to question 3, it says the diagram shows the point a1 comma 2 and b4 comma 4 on the curve. Y equals to 2 root x. The line we see is the normal to the curve at b, and c lies on the x-axis. Lines AD and BE are perpendicular to the x-axis. Find the equation of the normal BC. Okay, so there's a tangent here and there's a normal here as well. Let's try to draw that, okay, as accurately as possible. So there's a 90 degree. Okay, I want to find the equation of the normal, but I can't reach the equation of the normal without reaching the tangent first. So I'm going to try to differentiate this. This is 2x power half. So dy by dx is equals to half 2x power half minus 1. So I get x power minus half. Okay, then sorry, dy by dx at the point 4 is 4 power minus half, which is 1 over 2. That's the gradient of tangent. Gradient of normal is minus 2. In order to find the equation of the normal, I'm going to do y minus y1 at this point, m x minus x1. Okay. Okay, moving on to the next question then. Question number 4 says the diagram shows part of the curve this. Find the gradient of the curve where x equals to 2. So again, gradient of the curve is simple. I just bring it up so that I can differentiate it. I bring minus 1 down and I decrease the power, and then I multiply with the differential of the bracket. So I'm going to multiply by 3. So I get minus 18 3x minus 2 power minus 2. Then dy by dx, and I want to plug in the value to minus 18 3 times 2 minus 2 minus 2. 4 power minus 2 into minus 18. It's minus 9 over 8. I think that was relatively simple. Then question 5 says a curve has equation 4 over 3x minus 4 and 2 comma 2 is a point on the curve. Find the equation of the tangent to the curve at P. So I first bring it up. Again, what I need to do is dy by dx. So minus 4 3x minus 4 power minus 2 into 3. The differential of the bracket. Okay, then I use x equals to 2. I have minus 12 3 2 minus 4 power minus 2. Okay, that gives me minus 3. Yeah, okay. I want to find the equation, so y minus y1 mx minus x1. Find the angle that the tangent makes with the x-axis. So the angle between line and x-axis is tan inverse of modulus of m. Okay, so tan inverse of minus 3. Tan inverse of 3 gives me 71.565, which rounds off to 71.6. That was part 2. That's for coordinate geometry. Then it says the line this is a normal to the curve this. Okay, now this looks like it might be a quadratics question, but it's not because I'm talking about the normal. The quadratics chapter only talked about tangents. Okay, so what is the gradient of the normal? If I have the normal, can I bring it to the form y equals to mx plus c and tell you that the gradient is basically gradient of normal is minus 1/3, which means that the gradient of tangent would have been 3. Let's just find the value of the constant k. So I know that when if I do go on and say that dy by dx uh, is 2x minus 5. I can say that I can plug in the value. I can plug in the value 3 here and find out what x would have been. Okay, that gives me the value for x. Now, I also need the value of y that I can plug in here so that I can find k. I know that this normal was on a certain point. That point can be found out. I can say that 3y plus 4 equals to 25. 3y equals to 21 and y equals to 7. So the point at which we were doing all of this differentiation was 4 comma 7. Can I use that point to find k? Yes, I can do that. I can just say that 7 equals to 4 square minus 5 times 4 plus k. 16 minus 20 plus k. K equals to 11. Okay, so the next question says a curve has equation this. Find the equation of the tangent to the curve at the point 4 comma 0. I think that's simple. You just differentiate and you put in the value. I think all of them are in the form where you can differentiate easily and say that dy by dx is 2 times 3 over 2. If I subtract 1, it's going to become half minus 3 minus 4 into half x power minus half plus 0. And then I can just quickly go on and put in the value 4 and say that this is 3 times 4 power half minus 3 minus 2 times 4 power minus half plus 0. Okay, so that gives me 3 times 2 is 6 minus 3 minus 1, and that gives me 2. So then I can go on and construct an equation y minus y1 mx minus x1. So I get 2x minus 8. I think that's relatively simple. Question number 8 says the diagram shows a curve this and the point this and this. Find the equation of the line AB, giving your answer in the form y equals to mx plus c. Okay, that is reasonably easy as well. And we can say that I can just find the gradient of AB and say that this is going to be 2 minus 0 over 5 minus 1. Gives me 2 over 4, which is half, and y minus y1 mx minus x1. So 2y equals to x minus 1, and that's the equation of AB. And it says find showing all necessary working the equation of the tangent to the curve which is parallel. So there must be a tangent that's parallel here, and let's quickly go on and do that. So what I'm going to say is that whatever the gradient of AB was, so the gradient of AB is equals to the gradient of tangent. And how do I find the gradient of tangent? By uh, using differentiation. So I'm going to differentiate this and say that dy by dx is half x minus 1 power half minus 1 into 1, basically, because 1 is the differential of the terms in x that are inside the bracket. Okay, then I can say that this is half gradient of tangent is half x minus 1 power minus half. Now I'm doing all of this because I want to find the value of x, because in order to construct an equation I will certainly need the value of x to find the value of y then as well. This cancels out and I have 1 over x minus 1 power half. Okay, and then I have x minus 1 power half equals to 1. I square both sides and I end up with x minus 1 equals to 1, so therefore x equals to 2. When x equals to 2, I can say that I can plug in x to find out y. I have the point as 2 comma 1. There's a point called 2 comma 1 that seems like it might be the point of tangency. Okay, can I find the equation? Y minus y1 m x minus x1. So I get 2y minus 2 equals to x minus 1. 2y equals to x plus 1 basically. And oh, I've put in x and y incorrectly. X is 2. Yeah, so that changes a lot of things. It's 0. So 2y equals to x. Okay, I needed the first answer also in the form y equals to mx plus c. I don't think I've done that. Let's do that because it's important to follow the requirements of the question. The other one didn't. Okay. Then it says find the perpendicular distance between the line AB and the tangent parallel to AB, giving your answer correct to two decimal places. Now there are lots of ways to do this question. One way is that you can either go on and find this angle, and that should simplify things for you. The essential part is that I'm trying to find this distance. Okay, it's the perpendicular distance between the line AB and the tangent parallel to AB. Now, in order to find this distance, um, if I were to create a triangle somewhere, okay, this distance would be the same as this distance, and say I can say that this is at 90 degrees. I know that this distance is 1, so I think finding out the angle will help me. How do I find out the angle? I know that the angle between the line and axis is tan inverse of m. So tan inverse of half in this case. So tan inverse of half gives me what? Tan inverse of half gives me 26.565. Okay, then I can say that since I have this triangle, I can say that this is the right triangle. The hypotenuse is 1. I want to find out the perpendicular, so I'm going to say that sine 26.565 equals to distance over 1. So it is sine of 26.565. That's 0.447. Yeah, 0 point correct to two decimal places is 0.45. Okay. Question 9, it says the line y equals to ax plus b is a tangent to the curve y equals to 2x cubed at the points this. Find the values of the constants a and b. So if this is a tangent, the gradient of this must be equals to the gradient of that. Okay, so that's the first thing I can do. I can say that dy by dx is equals to 6x squared minus 10x minus 3. If I plug in dy by dx at x equals to 2, that gives me 6 times 2 squared minus 10 times 2 minus 3. That gives me 24 minus 20. 4 minus 3 is 1. So the value of a is 1. Okay, that was the gradient here. It's m. Okay, so I found that. Then I can say that if I have this as 1x plus b and the point of tangency is 2 comma 6, say that this should be 1 into 2 plus b, so b should be 4. Okay, and for c I can just plug in the point directly here and say that this is the point that I need to find. Okay, 2 times 8 minus 20 minus 6, 16 equals to c. So I think just written down the answer for c here. We can check that against the numbers. Okay. Question 10, it says find the coordinates of the otherwise the gradient is 4 over 3. So I'm going to say that I will differentiate this first. I will first write this in the form 25 minus x squared power half. So dy by dx is 0 plus half 25 minus x squared half minus 1 into minus 2x. Okay, and I want to find out the gradient is 4 over 3 at what point. Okay, Since this equation has a root, I will have to take a square on both sides and say that this is 16 over 9 x squared, 25 minus x squared. Nothing cancels out, but 16 into 25, 400 minus 16x squared equals to 9x squared. That's 25x squared equals to 400. 400 divided by 25 will give me 16, of course. And x could be either 4 or minus 4. Okay, but I will have to check which answer actually gives me a gradient of 4 over 3, because I removed the root, which means that I must have forgone something, and that is what I need to check. So what I'm going to do is I'm going to go to my dy by dx again, which is minus x 25 minus x squared power minus half, and see which one gives me the correct answer. So when I plug in 4 at 4, it gives me minus 4, 25 minus 4 square power minus half. So that gives me minus 4 over 9, minus 4 over 3. Okay, that's from my calculator. So not the gradient in the question. So I'm going to use the other point, and the other point will definitely give me the plus sign that I want, because the origin, the value of x is minus 4. So x is minus 4. How do I find out y? I just plug it in here and say that 2 plus root of 25 minus 4 squared, and that gives me 5. So the point is minus 4 comma 5. Okay, that's the end of worksheet 1. I'll be back with another video for worksheet 2. Thank you for watching.